Hello, everybody. Today we are going to be doing congruent triangles, day 2. Our notes are on pages 13 to 16, and then our homework tonight is in the packet, pages 17 and 18, and flashcards 5 and 6. So I wrote that up here for us. Pages 17, 18, flashcards 5 and 6. Let's get right into the lesson for today. We have two properties that we've been doing since we were little, addition and subtraction. But once we put letters instead of numbers, it gets trickier. If A equals B and C equals D, then when I add A and C, it should equal when I add B and D. This also works for congruent pieces instead of equal, because we'll usually be talking about like segments or angles and not just numbers. Let's look at an example. If A is 7 and B is 7 and C is 4 and D is 4. So I just picked random numbers that made this true. A equals B, we were told that. C equals D, we were told that. So that means 7 equals 7, 4 equals 4. Makes sense so far. Looking at the numbers then, if I take A plus C, that would be 7 plus 4. If I take B plus D, that would equal 7 plus 4. Well, 7 plus 4 equals 7 plus 4. So it makes sense with numbers. Now we just have to switch it to letters. If we have congruent pieces added to congruent pieces, then the totals are equal. So let's look at it again. With the subtraction property, I'm going to use the same numbers from up here. So I know A and B are equal. They were both 7. C and D are equal. They're both 4. So now if I take A minus C, 7 minus 4, and I take B minus D, 7 minus 4. Well, these two things were both 7. These two were both 4. So my answers should be equal. If we have equal parts and we take away from equal parts or whole things, then what's left should also be equal. So now let's look at this a little bit more geometrically. We will do one proof example with numbers and letters, and then we're not going to use the numbers anymore. AB is 2. BC is 3. ED is 2. EF is 3. They want us to prove that this whole thing equals this whole thing. In any proof, we start with our givens. Our brains, this makes sense. We know if we add these, we get 5. If we add these, we get 5. 5 equals 5. We have to show it with the letters and the pieces instead of the numbers. When we start these, I want you to think about the whole thing first. One of the whole things is AC. I can get AC if I add 2 and 3, or I can get AC if I add AB plus BC. Let's give these some colors here. So I can get AC if I add purple and pink. Then if I come down here, I can get DF if I add purple and pink. The reason we can do this is a theorem that we talked about on the previous page. The whole segment, so all of this equals the sum of its parts. The whole thing equaled when I added these together. This whole thing equals when I added these together. The whole thing equals the sum of its parts. In my next step, I'm going to look at this a little bit differently. I know that these two things are equal. Those are both my purple pieces. AB equals DE. I also know that the pink pieces were equal. BC equals EF. So if I add the equal parts to equal parts, my results would be equal. If we think about it with the given numbers for this problem, 2 plus 3 is 5, 2 plus 3 equals 5. We just took facts that we already knew and changed how they were written. The reason we can do this, we talked about that on the first page, is just addition, the addition property. If we take two things that are equal, add two things that are equal, our answers are equal. One more step. We are going to kind of move some things around to get what we want. Our goal was to show that AC, the whole thing, equals this whole thing. When I come up here, AC equaled part plus part. Well, that part plus part is here. Instead of writing it as part plus part, purple plus pink, I can write it as AC. DF equaled part plus part. That part plus part is down here. Instead of writing it as two pieces, I can write it as DF. We are just using substitution or substituting to get what we want. Let's look at another one. Angle 1 equals angle 3. This guy equals this guy. And angle 2 equals angle 4. They want us to prove that the whole angle equals this whole angle. Well, we can see it. We can see that pink plus purple gives us equal whole things. We have to talk about it. Got my givens to start. The next thing we do is think about the whole thing. One of my whole angles, ABC. I can get this angle by adding angle 1 and angle 2. My other whole angle is angle DEF. I can get this whole angle by adding angle 3 and angle 4. So all we just did was think about the whole segment. The whole, except this time it's not a segment, this time it's an angle. The whole angle equals the sum of its parts, or adding the smaller angles. Now we're going to rewrite this differently. I know that angle 1 equals angle 3. I know that angle 2 equals angle 4. Well, if I take these greens that are equal, and I take these blues that are equal, the answers will be equal, just like we thought about on previous pages. If this is like the problem above 2 and 3, 2 and 3, just giving it some numbers, the left side will equal the right side because that's how adding works. That's just addition. This help us? This helps us because we wanted to prove the whole angle equaled this whole angle. I have enough to do that because this angle, ABC, equaled angle 1 and angle 2. So instead of writing it as angle 1 plus angle 2, I'm going to write it as angle ABC, the top angle. I know that when I added these two things here, it equaled something else. It equaled this. Well, I see this somewhere else too. It's up here. Instead of writing equals angle 3 plus angle 4, I can write it as equals angle DEF. All we did was take a bunch of equal things and substitute them, use substitution to get what we wanted. In both of these problems, we were proving a total, this total angle. In this problem, we were proving a total, this whole line segment. If we are proving a total, we have to add together to get bigger. So when we have an addition proof, we're going to think about was, W-A-S. After our givens, we think about the whole thing, the whole segment. Then we think about adding in our addition property. We end by substituting to get what we want. W-A-S. Down here, addition, W-A-S, was. Addition proofs, we think of was. But with addition also comes subtraction. So now we're going to do some subtracting proofs. They're telling us here, they won't always tell us, so we have to know if it's subtraction or addition. They're giving me AB equals DE. And the whole thing equals this whole thing. They want us to prove that just a little piece equals just a little piece. If we're just trying to prove a piece of it, we have to get smaller or subtract. So I'll have my givens. Just like with the addition, we're going to start with the whole thing again. So we're going to have W first. Think about the whole segment. AC equals AB plus BC. Think about the whole thing. DF equals DE plus EF. The whole segment equals the sum of its parts. The whole thing equals when I add the pieces together. But we are not adding anything. We are going to be subtracting. So instead of WAS, subtracting proofs are WSS. Step 3 is going to be an S. And I gave away the next letter is going to be a U, but we need to be careful with it. So in step 3, our statement is going to look a lot like it did on the other page. On the other page, we added the parts equals added the parts. But our reason is different over here. So I'm going to say AB plus BC equals DE plus EF. But this time, I know that's true because of substitution. I know it's true this time because they told me the whole thing and the whole thing are equal. If I know these are equal, I'm going to set its counterpart equal to this one's counterpart. They told me these were equal. I substituted what I wanted. Step 4 is another S. Well, it's a subtraction proof. That's got to come in somewhere. Step 4 is subtraction. Subtraction works when we take things away and get equal things. So if I looked at this last step, I know from the givens that A, B, and D, E are equal. If I subtract or take away these two pieces that are equal, I get BC equals EF, which was exactly what we were trying to prove. We took away two things that were equal, we subtracted to get what we wanted. So with subtraction proofs, WSS. We start with the whole thing. The S's confuse a lot of people. So I'm going to tell you, think about your alphabet. They're both sub. In the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S comes before T. So substitution comes before subtraction. We've got one more like this. I'm telling you this time that this one is going to be addition. I guess it's not like the other page, but we do have another proof to do. They're telling us some things are equal. AC and AB are equal. CE and BD are equal. Prove that ADE, prove the whole thing is isosceles. Well, in order for it to be isosceles, we need two congruent sides. I can prove that AE is congruent to AD. If I add these pieces, I get these pieces. It's addition. We want to get bigger to the whole side, so we have to add. Start with our givens. With addition and subtraction proof, we're either thinking was or was. If I'm adding, I want was. Whole. The whole equals the sum of its parts. The whole AE equals pink plus purple. The whole AD equals its pink plus its purple. I know that's true because the whole side or the whole segment is equal to if I add its pieces, or to the sum of its parts. There's our W, A, addition. So our next reason is addition. The addition property lets us add things that are equal to other things that are equal. So I know in this question, the pink and the pink are equal. AC and AB are equal. I also know purple and purple are equal. CE plus BD. If these are equal and these are equal, our totals are going to be equal. Even though there's no numbers in this problem, let's just think for a second. Just picking random numbers. If I add 2 and 5, I'm going to get the same thing as if I add 2 and 5. This total equals this total. So there's our A, WA. We're not going to have an addition and a subtraction proof together, so this S has to be substitution. What can I substitute or rearrange to get what I want? Well, I want AE and AD to be equal. Here I have AE. Well, AE equals adding its parts together. Here's its parts. Its parts equal this. But this equals this. So instead of using these two pieces, I'm going to call it its whole thing. Instead of using these two pieces, I'm going to call it its whole thing. AE is congruent to side AD. We're not done yet for this one. One more quick step. If these two sides are equal, that means triangle ADE is isosceles, because a triangle is isosceles if and only if it has two congruent sides. So on your homework tonight, if it's addition, you're going to follow the examples we did. It's just a pattern. Do WAS specific to that problem. If it's subtraction, you're going to do WSS, follow the example we did, plug in things specific to that problem. Next class, I will check days 1 and days 2 for your homework.